All right, to start off this week, we're actually going to do a little demonstration that I'm going to do for you guys. Um, it's going to be based on the chapter 2 of the textbook because we just talked about bonds in our last class, and we learned that salt is an ionic bond between sodium chloride, right, NaCl, sodium Na chloride Cl, and that means that they completely swapped an electron, and now they are the Na and the Cl are stuck together because the Na has a positive charge from letting go of an electron, and the Cl has a negative charge from accepting that electron, and it completely holds on to it, so they don't share it at all, but they're attracted to each other because they have a positive and a negative. We also talked last time about hydrogen bonds, which water has, because when you have oxygen, which is super electronegative, and it holds onto the electrons that it's sharing more times than the hydrogen that it's bonded with, right? H2O is one oxygen and two little hydrogens stuck to it. And the hydrogens are very not electronegative. So they are not holding on to the electrons for as much time as it's rotating around the oxygen versus the hydrogens. Okay, that means that it is a polar covalent bond. Therefore, there are dipoles, which means there's a more positive side and a more negative side, right? The oxygen is going to be more negative because it holds the electron more often than the hydrogen. And the hydrogen is going to be more positive because it doesn't have the electron there as often to balance out the nucleus. So we're going to kind of look at the impacts and kind of effects that has on life just by doing a small demonstration of, solubility and what reacts with what. Now, let me share the screen real quick. So our mini investigation is going to be in your journals. So before we continue with chapter 2, I want you to title your mini investigation on a brand new page in your journal and write the date for today. And I want you to write 2 if-then hypotheses. Okay, the first one being about if we put table salt in water, what happens? And the second one being about if we put table salt in vegetable oil, what happens? Now I have some olive oil here. I have regular table salt, and I have regular drinking water. And those are the things that we're going to be mixing. So before you even go ahead, just think to yourself, do oil and water mix? Just think, right? Oil and water actually don't mix with each other because water, remember we just said, is a polar covalent bond. So it has a positive and a negative somewhere on the molecule. And a lot of them together like to stick to each other because the positives and the negatives like to stick with each other. On the other hand, oil is a non-polar covalent, which means that across the molecule, there's no positives or negatives, right? So water and oil, we already know, don't mix. When you pour oil and water together, oil actually stays on top of the water. And you can actually see the perfect line divide if you haven't shaken it recently between the oil and the water. Okay, so we know that they're not mixing fluids, and we're going to put salt into both of them. Okay, so for the first hypothesis, the setup is basically going to be if we pour table salt, parentheses NaCl, into water, parentheses H2O, then, and you're going to tell me if you think it dissolves or not. And your second hypothesis is going to be if we pour table salt, NaCl, in vegetable oil, then blank. You're going to tell me if you think it's going to dissolve or not. And we're not going to do a null hypothesis because this is a purely observational introduction demo. And if we don't have numbers, we can't do a chi-square. So there's no point in doing that. So we're just going to kind of do an easy in and out of this introduction into water properties. Okay, so now I'm going to switch to a setup where you can see where I am going to pour out the oil and the water, and then we're going to see what happens when we pour the salt into there. Okay, and then based on that, you're going to write me up like a short little logical conclusion of what's happening and why it happened. Now here you can see I have a spoon to be pouring the salt in and mixing it. And then I have 2 cups. One of them is going to have oil in it, and then one of them is going to have water in it. Okay, the oil is really, really obviously yellow, and it's olive oil. So you'll see that in a second when I pour it in. It's got a yellowish tinge to it. And you can kind of see that there are bubbles that hold into it, and they don't stay for a long time. And then in the other cup, I'm going to pour regular drinking water, literally from my water bottle. And I'm gonna pour about the same amount in both cups, right? So we're not gonna say that the amounts are the cause of something, if the salt dissolves or not, right? Because they're pretty much the same level inside. I could probably pour a little bit more oil, but you get the point, right? So this is the oil right here, and then this is the water, okay? So the two of them are in separate cups, and I'm going to be putting salt or NaCl into them, okay? So I'm gonna pour approximately 1 spoon. And before this, again, pause if you haven't already, but write out your two hypotheses, one for the salt cup, sorry, one for the water cup and one for the oil cup of your prediction if salt will dissolve or not inside of them. Okay, so I have some salt in my spoon. Ooh, and you saw me just spill it everywhere. And I'm pour some salt into the oil and some salt into the water. Okay, and then I'm gonna go ahead and kind of clean up my area because now there's salt everywhere. And I'm going to stir to see if it dissolves. Now, you guys might already have some sort of background to know whether or not salt dissolves in water and oil, if you've ever cooked, right? And know that this is also temperature dependent, right? So if I stir the water cup with the salt in it, make your observation and write down one sentence of what happened to the salt in the water when I stirred it, right? Where is the salt now? What has happened to it? Can you still see it? Okay. On the other hand, I'm going to switch to the other side of the spoon since I just put the other side in the water. We're going to stir the one with the oil and the salt together and see what happens. Now, just by stirring it, you can kind of already tell that the oil is just a different kind of viscosity. It's a lot thicker than water is. And you notice that when you pour it too, because it doesn't really splash around because oil sticks to itself very well. Now, I am stirring. And I'll stir for about the same amount of time as I stirred the water, which is about like 15 more seconds. And what do you notice is happening? What is happening to the salt inside of the oil? Right? If you look inside of the cup that originally contained the oil and I poured the salt into it, you can actually see almost all of the salt grains are still present and that it has not dissolved, right? So now underneath your hypotheses, one for the water and one for the oil, you're going to write a conclusion sentence. You're just going to tell me, did the salt dissolve or not? And then under each of those sentences, you're going to write one sentence each, explaining why did the water dissolve the salt and why did the oil not dissolve the salt? Okay, think back to bonding, right? Think back to having charges, right? Because positive and negative attracts, right? So you're going to try to use that information to write out 3 sentences for each now, okay? So you're going to compile everything into 2 little paragraphs. One paragraph on the water, you're going to write your hypothesis, you're going to write the results, and then you're going to write why, right? So that's going to be what kind of bonds are present and why did they cause this result. Same thing for the oil. You're going to write your hypothesis. You're going to write what happened when I poured the salt in and stirred it around. And then you're going to write what kind of bonds are present in the oil and the salt and why did they interact this way to create this result. Okay, so that's going to be our little demo. I want to see you guys come in with the write-ups, the short write-ups done into class on Monday so that we can kind of go over your explanation of bonds and move into the specific properties of water.